Hello and welcome to our project presentation. We have worked on the project of balancing chemical equation using Matlab. I am Abhi and this is our team, me, Pujan and Keyur. So let's begin with introduction. This project explore an alternative way to balancing equation of chemical reaction and understanding why it is necessary to use balance equation in science. Balanced chemical equations are fundamental in chemistry as they represent the conservation of mass in chemical reaction. They provide a concise and conjugative quantitative description of chemical reaction, showing the reactants and products involved and the stoichiometry of reaction. Balanced chemical equations are crucial tool in chemistry, providing a framework for understanding and predicting chemical reaction and are essential for wide range of application in the field. To balance a chemical equation, chemists often guess the coefficient that would balance the equation and check if it works. Balancing chemical equation by hand can be tedious and susceptible to mistakes. As the number of elements and the complexity of reaction increase, the definitely the difficulty in achieving a balanced equation rising significantly. This method becomes impracticable for complex reaction or those with unknown coefficient. So an alternative method is used to matrices to determine the coefficient of balanced chemical reaction. Next objective. The goal of this project is to develop a MATLAB program that can automatically balance chemical equation. This program will take as input unbalanced chemical equation and output the coefficient balance equation. By automating balancing process, the program aims to provide a quick and accurate solution to common challenge faced by students and researchers. The program will be designed to handle a wide range of chemical equations, including complex reactions involving multiple reactants and products. We will try finding an approach which not only save time but also reduce the likelihood of errors compared to manual balancing method. When first learning how to derive and balance chemical equation, most people tend to have a guess and check approach. This method can be time consuming and error prone, particularly for complex reaction. Not only is this method time consuming, it can also lead to inaccurate answer in more complex reaction. So we need a better, faster and more accurate method. Manually, balancing chemical equations can be challenging due to many factors. Most difficult part which I also faced when I used to balance is redox reaction. Balancing redox reaction which involves changes in oxidation state can be particularly challenging. Heat and trial at times become frustrating. Overall, manually balancing chemical equations requires a good understanding of chemical principle and the ability to apply them accurately. That is when we use matrices. An alternative method to derive the coefficient of the species in chemical reaction is use matrices. Matrices are an accurate way to balance complex chemical equation and are far less time consuming with the aid of calculator than the guess and check method.
Now let's quickly look at why balancing a chemical equation is important. First of all, conservation of mass. Chemical kinetics. Balancing equations are essentially for studying kinetics of a reaction as they provide the basis of determining reaction rates and mechanism. Third, predicting products. Also it look at stoichiometry. Overall, for a chemical equation to be balanced is a crucial part in chemistry to be useful. Let us look at how will the methodology of chemical equation with the matrices works. First point is input. The algorithm takes unbalanced chemical equation as an input, then counting the atoms. The algorithm first count the number of atoms of each type of atom on both sides of equation. By using the count of atoms, we create a system of equation. The algorithm set up a system of linear equation basis on the atom counts. Then we solve the system of equation. The algorithm solves the system of equation to find the coefficient that the balance equation. Here, here where we introduce the matrix algebra for balancing. Matrix algebra provides a powerful tool for solving system of linear equations. We can construct coefficient matrix to represent the number of atoms of each element in the reactants and products. Solving the system using techniques like row reducing helps use determines the balance coefficient. This method ensure a systematical and a current solution. And then we finally output. Balance equation is the display as the output of the algorithm.
So now let's quickly look at the MATLAB implementation of our project. The MATLAB implementation follows the codes. There are 5 code snippets. First code snippet looks like this. First function we define balance chemical equation, which obviously functions of balancing the chemical equation. Which also we should remember that we should name the file as the function of the chemical equation so that it runs correctly. Then we have the other function which defines a nested function parse command that takes a chemical compound string as input and returns a map containing the elements and their counts in the compound. The code following this function does exactly the job as stated before. Then we'll look at the second code snippet of the code. This code snippet describes and prompts the user to enter the compounds for LHS of the equation. Similarly, for the RHS of the equation, as we all know, chemical equation has two parts, LHS and RHS. The third code snippet for the code is as follows. The we run a loop, for loop, which determines the unique elements present in the LHS compounds of the equation. Similar job is done for the RHS of the equation, and the last lines states that it calculates the dimensions of the matrix A based on number of unique elements and compounds, initializing A as 0 matrix of appropriate size, which we see in the last 4 lines of the code snippet. The next code snippet has two nested loops, one for the LHS and other for the RHS. The first nested loops constructs a matrix A representing the coefficients of elements in the chemical equation. It iterates over the compounds on the LHS of the equation, and for each compound, it iterates again over the unique elements. That is why we have two for loops nested into each other. Similar job is done for the RHS side of the equation. This is the last code snippet of our project code, which uh, finds the null space of a matrix, and it finally prints or prompts the final coefficients of the balanced chemical equation. If the equation is not valid or does not have a unique solution, then too we have error handling for it. That is when it will display the no valid solution found message, etc. And if it has a solution, then it will simply display the uh, coefficients of the balance equation. We'll take a look at sample case. Here we have entered Fe and O2 as our LHS and Fe2O3 as our RHS. It forms a matrix A using the coefficients and finally giving us the coefficients of the balanced equation. We have other sample cases also which can be looked at afterwards. So these are the advantages of the automated approach. First, speed, of course, it makes it more faster because it's computer. Accuracy, it's of course more accurate than human efforts. Complexity, efficiency, education, etc., etc. We'll conclude the project. The project successfully demonstrated the use of matrices in MATLAB for balancing chemical equations. This approach eliminates manual counting errors and can handle complex equations as well. The program is user friendly and asks the user to input the LHS and the RHS of the equation. Overall, the project highlights the effectiveness of using MATLAB for balancing chemical equations in place of human efforts. These are the references, the websites we used. We also used a book. That is it from our side. Thank you.